In this video, I'm going to talk about representing binary relations. So there are two ways that we are going to talk about here: directed graphs and Boolean matrices. Okay, so we'll start with directed graph. First of all, what is a graph? A graph, G, we define that by sets V and E. But what are V and E? V is set of vertices, so most of them are sets. So it is the set of vertices, and E is set of edges. But again, what are vertices and edges? See, actually graphs are some things that we have like some dots and some line between them. Those dots are actually standing for showing some objects, and those lines which are connecting some of those dots or objects are connecting them, so they are actually standing for showing a connection between them. So let's assume that it is you, person A, and I show him by A, and one friend B, and someone else C. So what I know is that A, B, and C are people. So I show them by dots. And now I want to talk about the relationship, the friendship relation between these people. I know A and B are friends, and B and C are friends, but A and C are not friends. So I don't connect them, but I connect these people. Okay? So you see, friendship is something like in two ways. Sometimes we have some relations which are like one way. For example, each of these guys are selling something, and then each of them can buy something from the other one. So for example, if I have something like that, I define my edges as if I have A to B, it means that A bought something from B. So I know A bought something from B, B bought something from C, and A bought something from C, and C also bought something from A. So you see, I can, for example, connect these two, but in two ways. When it is one way, it means that B bought something from C, but not C from B. So it is the ways that we can define those edges in one way or two ways. So most of the time for two-way relationships, we don't use directed graph. We don't use those arrows. We just show that connection with lines. But when we use arrows, it means that not always, but every time we want to use one-way relationship, we need to use arrows to show that which way is the way we want. And you see, in relations, it is possible that I have something like 2 and 4 are in my relation, but not 4 and 2. For example, in divides relation, 2 divides 4, but 4 doesn't divide 2, right? So I can show that 2 divides 4 by one arrow or directed edge, but I cannot show that 4 divides 2 by a directed edge. I shouldn't connect them. So it is the way actually we define a graph set of V vertices, which is like single elements. Here it is like V is A and B and C. It is a set. And edges. Actually, edges are not set of like single items, because edges are showing which is connected to what. And when I have directed edges, the order matters. So I have, for example, A and B, B and C, A and C, C and A. If it is two-way, then I don't need to have both of these. I have like A and C, and it means that they are connected. I don't have any arrows on them. But here that I have arrows, I need to define all of these. In undirected graphs, A and C and A are the same, so the pairs are not ordered because again I don't have arrows. But in directed graph, the edges, the ordered pairs actually are ordered, so the order matters. A and C is different than C and A. So when I see B and C, I know that the arrow is from B to C. I cannot write it, I cannot show it by C to B. So graph is one way to represent our relations, and we are going to see one example here. Example 7 in the textbook. Not textbook, actually, lecture notes. And then we are going to talk about the second, like Boolean matrices. Okay, first of all, there is one difference between these two ways that when we use them. We use graphs or directed graphs when our relation is on one set. You see, when I said the relation R, the binary relation R is defined on set X. So as you remember, before I mentioned that when we say it is defined on set X, means that it is from X to X or X Cartesian. It is a subset of Cartesian product of X with itself, X cross X. For these ones, we can use graphs. But for the ones that we have like X and Y as two different sets, we cannot use graphs. So the vertices in my directed graph will be the elements in that A. So when I have relation R on set X, if it is X Cartesian product Cartesian Y, I cannot use Boolean matrix, directed graph. So here is like my nodes are X, all the elements in X, and my edges is the set of my relation is the same as R. So each ordered pair shows one directed edge. Okay, so this example 7 says that we have a D graph, the directed graph, G with V and E, vertices and edges, with vertex set X. Let's show that here. Let me use this part that I can write down. So example 7, the diagram G with V and E with vertex set V as U, V, X, W and Y, depicted as below. So I have this picture in that example. Okay, we have this diagram, and let's see, can I see what my relation is from this picture? Okay, see, what I can see is that V is related to itself, so I need to have the pair V and V. I see U is connected to V, U is going to W, W is going to U, U is going to X and Y as well, so UX, UY, W is going to Y, Y is going to X, and how many in total? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have everything here. So what I can say is that it is my relation. From this relation, I can connect them and represent them by a diagram. And also from the representation, I can see what my relation is. Okay, it was one way to represent our binary relations when we define that binary relation on one set. So it is Cartesian product of one set with itself. The next one, Boolean matrix, we can have two sets like X and Y, and we define that on Cartesian product of these two. So in the next video, I'm going to talk about the representing by Boolean matrix.